My name is Thijs Roumen, Hasso-Plattner Institute, and I welcome you on behalf of my co-authors to this talk on assembler cubed. Here is a wonderful model shared in the laser cutting community, which allows me to experience virtual reality using my phone. But it's not a very inclusive model. It was made with one particular user in mind, and for one particular laser cutter to fabricate on. So I would like to make some changes so that it becomes a useful model to me. As you can see, I have glasses, so I would like to modify the model so that it fits my prescription. And I would also like to be able to adjust the interocular distance so that the image becomes sharp for me. Reduce the weight so it's a more comfy model. And stretch it a little bit vertical so that it allows my phone to fit in. Recent research projects like FlatFab and kyub allow me to make 3D modifications to the models, which allow me to adjust the focal range here in a very trivial operation. I just use a stretch tool and I move the front plate forwards. Unfortunately, 95% of all models are shared in the form of 2D cutting plans. So if I want to make that same modification to the VR headset, I obviously need to change the top plate here. But in order to do so, I also need to plates that connect to that. So those are, for example, these two side plates, as well as the bottom plate, otherwise the model would be skewed. So I think what I just did in kind of figuring out which plates I need to modify is I mentally 3D reconstructed the model, imagined what the modification is that I want to make in 3D, and then execute that back on the 2D cutting plan. We ran a user study, and it turned out that on average for participants it took 24 minutes to perform this operation, and 11 out of 13 models failed when we fabricated them. So if users need to reconstruct a 3D model of the 2D plates anyway, why don't we go for 3D right away? So there already is software, as I just mentioned, that allows you to convert 3D models to 2D cutting plans, but there's nothing to go the other way around. So we built a system that's called assembler cube that uses a round trip to edit the 2D cutting plan via 3D reconstruction. This workflow turns out to be 10 times faster, and all models worked as a result. Let's look at what assembler cube really does. So assembler cube is a 5-step algorithm. First, assembler cube detects the plates in the model. Then it identifies joints on the model. Then it uses that information to derive the material thickness of the model. Then it tries to pair up the joints that fit together. And in the last semi-automatic step, users help the assembler cube algorithm to assemble the model. And in the interest of this talk, I'm going to focus on the last two steps of that algorithm. So here is the 2D cutting plan of that VR headset. We already found the joints in the model, but in order to now find out what joints match up with each other, we would have to compare every joint to every other joint in the model, which would at best lead to quadratic complexity for every step. This quickly becomes intractable. So instead, assembler cube creates a lookup table where all joints are hashed by the signature of their shape, which is known as a hash data structure. So here's, for example, that particular joint here. This is hashed by this signature of a shape. And by looking it up in the hash data structure, we immediately find, in constant time, we find the other candidates that it can pair up with. So rather than looking at all the joints in the model, we only have to look at this subset of 6 joints right now. And we're not quite conclusive yet, right? Because we still have 6 different options. So in the last step of the algorithm, we bring in the user to actually kind of disambiguate this last step. So the user here just loads the 2D cutting plan in the 3D editor. And now essentially puzzles together the plates using the assemble tool. You see that whenever I select one of the plates, only the joints that are relevant are highlighted, making this a relatively tractable operation for a user. And the great thing is, we have been in a 3D editing environment all along. So making a 3D modification to the model now is just using one of the other tools in the editor, in this case the stretch tool, to again fit it to my prescription. And so we used assembler cube to reconstruct 100 models that we found in online repositories that are now all 3D and all parametric in nature. So in conclusion, I have shown you how assembler cube allows users to assemble the plates together in a 3D environment, in this case cube, which effectively converted the 2D cutting plan to a 3D model. This allows users to make parametric modifications to the model and export it back to a format that works on any laser cutter. It turned out that this workflow is 10 times faster than the traditional workflow. Thank you for your attention.